We are going to start now lecture 6 of chapter 10 class 11th mathematics straight lines. So in this lecture we will start with the formula related to the distance between a point from a line. So the result we are going to prove, it is the length of the perpendicular from a point px1 y1 on the line ax plus by plus c is equal to 0. It is given by this formula. This is the formula for the distance between the point x1 y1 to the line ax plus by plus c is equal to 0. So to prove this result, we are using the fact, we are saying, suppose these are the x axis and the y axis. This is x axis, this is y axis. We are talking about a line L. This is the line L we are saying. The equation of this line, it is ax plus by plus c is equal to 0. Then if I write this equation in the intercept form, it will be x over minus c by a plus y over minus c by b is equal to 1. It means the coordinate of this point q, we are saying, it is minus c by a comma 0, and coordinate of this point, say we are saying this point it is r, the coordinate of this point it is 0 comma minus c by b. Now suppose we are saying there is another point p somewhere over here, and the coordinates of this point it is x1 comma y1, and we want to calculate the distance of this line from this point. So what we are going to do is, we are going to draw a perpendicular on this line from this point p. We have drawn a perpendicular on this line. Now if we join these 2 points, we are joining the point L and P, we are joining the point P and Q, and we calculate the length of this side. We are talking about LQ. The length of this side LQ, it is, we are talking about QR. This QR length we are saying, it will be square root of, we have the coordinates of these points, so it is c by a square plus c by b square. These are the, this is the length of this length we are talking about. We are talking about this point, it is m. We are saying this PM length we want to calculate. So area of the triangle, area of this whole triangle, we are saying area of triangle RQP, that is equal to half base is QR and the height we have, it is PM. This is the area of this triangle. Another way to calculate the area of this triangle is, we have the 3 coordinates, the coordinates of these endpoints we have. So if we calculate the area using these 3 coordinates, the formula we obtain, it is area of triangle RQP, that is equal to 1 by 2 mod x1 into minus c by b minus 0 plus 0 into 0 minus y1 plus minus c by a into y1 plus c by b. We are using these 3 coordinates that we have, and on solving this we obtain that the area we have, it is 1 by 2 mod, it is c minus c is there, then it is x1 by b plus y1 by a plus c by ab, mod of this value. And on solving this we obtain this value is equal to mod of c by 2ab into ax1 plus by1 plus c. So we have calculated the area of this triangle in 2 forms. One is, we are saying the area of this triangle, it is this value. Second, we are saying the area of this triangle, it is this value. Now if we equate both these values, the answer we obtain, we are saying on equating both these values, we have equated these values over here, and we are interested in calculating the value of PM, that is the distance, we are saying it is d. So the value of d that we will obtain, that is mod of ax1 plus by1 plus c divided by square root of a square plus b square, where the equation of the line we have, it is ax plus by plus c, and the point from which we are calculating the distance from this line, it is x1 comma y1. So what we have done, in place of x and y we have substituted x1 y1, and in the denominator we have square root of a square plus b square. So this is the final formula we obtain for the distance between the point and the line. Next is the length of perpendicular from the origin. So when we are talking about the distance from the origin, it means this point we are saying it is 0 comma 0. So the numerator part over here, this will become mod of c. Denominator part, it is square root of a square plus b square. So the distance of a line from a point, that is the point we are considering now, it is from the origin, it is given by mod c over square root of a square plus b square. Next is the distance between two parallel lines. So we are saying, suppose we have two parallel lines. These are the x-axis and the y-axis. This is x-axis, this is y-axis. We have two parallel lines. One is this line, another line is this line, and we want to calculate the distance between these two lines. The equation of the first line, we are saying it is ax. We are saying the equation of the line, this, it is ax plus by plus c1 is equal to 0. These two lines, these are parallel. So the equation of the second line, it is ax plus by plus c2 is equal to 0. Now in this second equation, if we substitute the value of y is equal to 0, we obtain x is equal to minus c1 by a. It means this point we obtain, it is minus c1 by a. Now if we calculate the distance of this line from this point, we are talking about the distance of this line from this point, the answer we obtain, it is mod of a into the coordinates of this point, it is minus c1 a0. So it is minus c1 by a plus b into 0 plus c2 divided by, we have square root of a square plus b square. So this a gets cancelled. So what we obtain, this value, it is c2 minus c1 divided by square root of a square plus b square. Now if this given line, the lines that are given to us, it is given to be they are parallel. Suppose their equation, they are y is equal to mx plus c1 and y is equal to mx plus c2. Their slopes, they are same because both these lines, these are parallel. So we are saying the formula we obtain in that case, d that we obtain, it is c2 minus c1 divided by square root of 1 plus m square. So you can use any one of these two formulas. Either you can use this formula or you can use this formula depending upon your problem to calculate the distance between two parallel lines. Next is some problems based upon these results that we have studied. So first is to find the distance between the point 4, 1 from the line 3x minus 4y plus 12 is equal to 0. So we are directly applying the formula over here. So it is 3 into 4 minus 4 into 1 plus 12. We have mod of this value divided by square root of these values. We have 3 and 4. So it is 3 square plus minus 4 square. So the answer we obtain, it is 20 by 5, that is equal to 4 units. Next is find the distance of the point minus 1, 1 from this line. So if we simplify this value, we get it is 12x plus 72 is equal to 5y minus 10. So the equation becomes 12x minus 5y plus 82 is equal to 0. Now distance of this line from the point minus 1, 1, it is given by 12 into minus 1 minus 5 into 1 plus 82 mod of this value divided by square root of 12 square plus minus 5 square. So answer we get, it is 65 by square root of 169, that is 65 by 13, that is equal to 5 units. So the distance of this point from this line, it is 5 units. Next question we have is, find the length of the perpendicular from the point A comma B to the line x by A plus y by B is equal to 1. So to calculate the length of the perpendicular means we have to calculate the distance. So we can write this equation in the form bx plus ay is equal to ab, that is bx plus ay minus ab is equal to 0. So distance of this line from the point AB, it is given by b into a plus a into b minus ab mod divided by square root of a square plus b square. So the answer we get from this AB gets cancelled, we are left with this mod of AB divided by square root of a square plus b square units. So this is the distance of this point from this line, and this also represents the length of the perpendicular. Next is, find the length of the perpendicular from the origin to this line. So we know the formula we have, it is from the origin means we are talking about the point 0 0. So we get it is 4 into 0 plus 3 into 0 minus 2 mod divided by square root of 4 square plus 3 square. So the answer we will get, it is 2 by, this is 16 plus 9 25 and 5. So it is 2 by 5 units. So this is the distance of this line from the origin. Next is, if P is the length of the perpendicular from the origin to the line whose intercept on the axis are A and B, it means we are talking about the equation of the line, it is x over A plus y over B is equal to 1, that is bx plus ay minus ab is equal to 0. The distance of this from the origin 0 0, it is given by ab mod of ab divided by the values we obtain, it is square root of a square plus b square, and this value is given to be equal to p. So if we square both sides of this equation, we obtain a square plus b square upon a square b square, that is equal to 1 by p square, and this value is equal to 1 by b square plus 1 by a square, and this is what we have to prove, that 1 by p square, that is equal to 1 by a square plus 1 by b square. Next is, find the perpendicular distance of the line joining the points. These are the 2 points given from the origin. So first of all, we are calculating the equation of this line. So it is y minus sine theta divided by x minus cos theta, that is equal to sine phi minus sine theta divided by cos phi minus cos theta. So if we simplify these values or rearrange these terms, we obtain this value we are talking about. This is equal to cos of phi plus theta by 2 divided by minus sine of phi plus theta by 2. So on cross multiplying, the equations become x into cos of theta plus phi by 2 plus y sine phi plus theta by 2, then we have minus cos of phi minus theta by 2 is equal to 0. When you cross multiply these terms and simplify the value, you will obtain the equation of the line joining these 2 points in this form. Now we have to calculate the distance from the origin. So the formula we have, it is mod of minus cos phi minus theta by 2 mod of this value divided by square root of cos square phi minus phi plus theta by 2 plus sine square phi plus theta by 2. Sum of both these values, this is 1. So denominator will become equal to 1. So the distance between 2 points we obtain, the value of d we obtain, it is mod of cos of phi minus theta by 2. So this is the distance of the line joining these 2 points from the origin. Next is, if P1 and P2 are the lengths of perpendicular from the origin to the line, the equation of the line is given. These are the two equations given. We have to prove that 4 times P1 square plus P2 square is equal to A square. So we calculate the distance in both the cases. For the first case, the answer we will have, it is mod of A divided by the distance we will have, it is secant square theta plus cosecant square theta square root, and this value is given to be P1. In the second case, we have it is mod of A cos 2 theta divided by square root of cos square theta plus sine square theta, that is equal to P2. Now if we look at this value, this term will become equal to 1. If we solve this value, it is 1 over cos square theta plus 1 over sine square theta. So that is equal to 1 by cos theta sine theta square. It is under root on this term. So this value will become mod of A into cos theta sine theta, that is equal to P1. Now we have to calculate the value of 4P1 square plus P2 square. So we get 4P1 square plus P2 square, that is equal to, we get the value from this, it is 4A square cos square theta sine square theta plus this value we will get, it is A square cos square 2 theta. Now look at this term, it is cos theta sine theta. If we multiply and divide it with 2, we get this numerator part, it is sine 2 theta by 2. So we are writing, in place of this term we can write it is sine square 2 theta by 4. 4 get cancelled, A square is common, we are left with this sine square 2 theta plus cos square 2 theta. Sum of both these values comes out to be 1. The answer we get, it is equal to A square. And this is what we have to prove, that the sum of these two values, that is 4P1 square plus P2 square is equal to A square. This is the result that we have to prove. Next is, what are the points on the y-axis whose perpendicular distance from the line, this is 3 units. So the equation of the line we can write, it is 4x minus 3y is equal to 12. We can write it is 4x minus 3y minus 12 is equal to 0. So its distance from the, what are the points on the y-axis? Points on the y-axis means we are interested in calculating the points of the form 0, b. Its distance from 0, b, it is 4 into 0 minus 3 into b minus 12 mod of this value divided by square root of 4 square plus 3 square. This distance should be equal to 3 units. So on solving this term will become 0. We get 3b plus 12 is equal to, when you solve this value you will get it is 5, 15. We have mod over here. So we are talking about the value that mod of 3b plus 12, this is equal to 15. This implies us two cases, that 3b plus 12 is equal to 15 or 3b plus 12 is equal to minus 15. So this implies us 3b is equal to 3, so b is equal to 1. This is 3b is equal to minus 27, So this implies as b is equal to minus 9. So the points we will obtain, it is 0 comma b. So either the point is 0 comma 1 or the point is 0 comma minus 9. So these are the 2 points on the y-axis whose perpendicular distance from this line is 3 units. Next we have is find the distance between parallel lines. These are the 2 parallel lines given to us. Now we can write, we know that the formula that we have, it is mod of C2 minus C1 divided by square root of 1 plus m square, where we are having two equations, y is equal to mx plus C1 and y is equal to mx plus C2. So we reduce both these equations to these forms. So this first equation, it will be of the form y is equal to minus 15 by 8x plus 17 by 4, and the second equation becomes y is equal to minus 15 by 8x minus 31 by 8. So in both these cases the value of m we have, it is minus 15 by 8, that is both these lines, these are parallel. Value of C1 we obtain, it is 17 by 4, and C2 we obtain, it is minus 31 by 8. So the distance, using this formula, the distance between these two lines, it is given by mod of minus 31 by 8 minus 17 by 4 divided by square root of 1 plus minus 15 by 8 square. So answer we get, it is minus 65 by 8 mod over here divided by, when you solve this value you will get, it is 2525 divided by 64. So this will become 289 divided by 64. So we are getting, it is 65 by 8 into 8 by 17. So answer we get, it is 65 by 17 units. So this is the distance between these two parallel lines. Next is find the distance between the lines 3x minus 4y plus 9 is equal to 0 and 6x minus 8y minus 17 is equal to 0. So first of all we are going to check whether these two lines, these are parallel or not. If these two lines, these are not parallel, then the distance between them will be 0. So we are writing them in the slope intercept form. So we write, it is y is equal to 3 by 4x plus 9 by 4. Second equation, it is y is equal to 3 by 4x minus 17 by 8. The value of slope for both these are equal. We are seeing the value of m for both these, it is 3 by 4. So both these lines, these are parallel to each other. For this first line we have, it is C1. For the second line it is C2. So we are saying that the distance between these two lines, it is C2 minus C1 divided by square root of 1 plus m square. The answer we obtain, that is equal to minus 17 by 8 minus 9 by 4 mod divided by square root of 1 plus 9 by 16. So the values we obtain, it is minus 35 by 8 into 4 by 5. So the answer we get, that is equal to, this get cancelled, we get, it is minus 7 by 2 units. It is plus sign over here because mod is there. So the distance between these two parallel lines, we have proved that both these lines, these are parallel, and the distance between them, it is 7 by 2 units. If suppose these two lines are not parallel, then the distance between these two lines will be 0 units. That is, they are intersecting lines. Next is prove that the line 5x minus 2y minus 1 equal to 0 is mid parallel to the line this and this. Mid parallel to the line means, we are saying these are the two lines, parallel lines given to us. Mid parallel line means a line which is parallel to both these lines, and the distance between all these lines, they are equal. The distance of this line L3 from L1 and L2 is equal, or we are saying this L3 is passing from the middle of these two parallel lines. So what we have to do is we have to prove that all these three lines are parallel. Then we have to prove that the distance between L2 and L3, that is equal to distance between L1 and L3. So we write the equations of all these three lines in the slope intercept form, and we obtain the first equation. We can write it is y is equal to 5 by 2x minus 1 by 2. Second equation we can write it is y is equal to 5 by 2x minus 9 by 2. And third equation we are writing it is y is equal to 5 by 2x plus 7 by 2. So these are the three equations that we have. This is the line. Say we are saying this is L3, this is line L1, this is line L2. Now we have to calculate. One thing is clear from this, that all these three lines, these are parallel to each other. Now we are calculating the distance between L1 and L3. So the value we obtain it is mod of, this is mod over here, the value we obtain it is mod of minus 9 by 2 plus 1 by 2 divided by square root of 1 plus 25 by 4. The answer we obtain it is 8 by root 29. This is the distance between these two lines. Next we are calculating the distance between L1 and L2 and L3. Distance between, this is D1 we are saying, D2, that is between L2 and L3, that is mod of 7 by 2 plus 1 by 2 divided by square root of 25 by 4 plus 1. On solving this we will get it is 8 by root 29. So what we obtain from this is that the distance between L1 and L3 and the distance between L2 and L3, they are equal. Second thing, we have already proved that all these three lines, these are parallel to each other. So combining these results, we are saying that this line is mid parallel to these two lines. Next is find the equation of the line midway between the parallel lines, these two. So first of all we are writing both these equations in the slope intercept form. So it is y is equal to minus 3 by 2x plus 7 by 6. Second equation we have it is y is equal to minus 3 by 2x minus 3. So slope of both these lines, the slope of both these lines m, that is equal to minus 3 by 2. And this will be the slope of the line which will be parallel to both these lines. Now what we have to calculate is that it is being given that the new line that we have to calculate, we are saying these are the two lines we are talking about. We have to find the equation of a line passing which is parallel to both these. The slope of all these lines, it is minus 3 by 2, and it should pass midway between these two lines. So suppose we are saying the equation of this required line, the equation of this line, this is y is equal to minus 3 by 2x plus some value c. Then the distance between, suppose we are saying this is line L1, this is L2, this is L3. Then distance between L1, L3 and L2, L3 should be equal. Now if we calculate this distance, we are saying the value of mod of 7 by 6 minus c, that should be equal to mod of minus 3 minus c. So we are having two cases now. We are saying 7 by 6 minus c should be equal to, minus sign is cancelled, it is 3 plus c, or 7 by 6 minus c should be equal to minus 3 minus c. So from this equation we will obtain nothing, this is not possible, and from this equation we will obtain 2c, that is equal to 7 by 6 minus 3, that is equal to minus 11 by 3. So the value of c that we will obtain, it is minus, the value of c we will obtain it is minus 11 by 12. The value of slope of this line m we have already obtained, it is minus 3 by 2. So the equation of the line, the equation of the required line, it is y is equal to minus 3 by 2x minus 11 by 12. So this implies us 18x plus 12y plus 11, that is equal to 0. So this is the equation of the line midway between the parallel lines, these two. Next is find the coordinates of a point on the line x plus y plus 3 is equal to 0, whose distance from the line x plus 2y plus 2 is equal to 0 is square root 5. So it is not being given that these two lines, these are parallel. We are having one line is this, say another line is this. We want to calculate, this is the line, say x plus y plus 3 is equal to 0. This is the line x plus 2y plus 2 is equal to 0. We have to calculate a point on this line whose distance from this line, it is root 5. Suppose this point we are saying, the coordinates of this point, it is a comma b. Then the distance of between these two, that will be given by a plus 2b plus 2 mod divided by the value we will have over here, 1 square plus 4 square, that is root 5. We are saying it should be equal to root 5. Second, so from this we obtain mod of a plus 2b plus 2, that should be equal to 5. This gives us two equations. A plus 2b is equal to 3, or a plus 2b is equal to minus 7. Now if this point, it lies on this line, so it will satisfy the equation a plus b is equal to minus 3. So we are solving these two equations. We are having one pair of equations we have is a plus 2b is equal to 3, a plus b is equal to minus 3. Second is a plus b is equal to minus 3 and a plus 2b is equal to minus 7. Now on solving these pairs of equations, the answer we obtain, suppose we subtract these two equations, we will get it is b is equal to 6 and a is equal to minus 9. On solving this, if we add these, subtract these equations, we will obtain minus b is equal to, the value we obtain from this is 4. So value of b we are getting it is minus 4 and the value of a we are getting it is 1. So we are saying there are 2 points on this line. One is the point minus 9 comma 6 and second point we have it is 1 comma minus 4. From both these points, the distance of this line is square root 5 and both these points, they lie on this given line. Next is find the point of intersection of the lines this and this. So to calculate the point of intersection, we know that we have to solve these two equations. So it is 5x plus 7y is equal to 3, 2x minus 3y is equal to 7. So the point of intersection we obtain, it is x divided by, we leave this coefficient, we are left with these two equations. So it is minus 49 minus 9, that is equal to y by minus 6 plus 35, that is equal to 1 by minus 15 minus 14. So we are using cross multiplication over here. You can use any method of your choice to solve these equations. So we will obtain the value of x is equal to 2 and y is equal to minus 1. So we are saying the point of intersection of these two lines, it is 2 comma minus 1. This is the point of intersection of these two lines. Next is find the equation of the line parallel to the y-axis and drawn through the point of intersection of these two lines. So we are calculating first the point of intersection. Equations we have, it is x minus 7y plus 15 is equal to 0 and 2x plus y is equal to 0. On solving these two equations, we will obtain x is equal to minus 1 and y is equal to 2. So the point of intersection we have, it is minus 1 comma 2. Now it is being given that the line is parallel to y axis. It means the equation, we are saying we are interested in calculating a line which is passing through the point minus 1 comma 2. This point it is minus 1 comma 2 and it is parallel to y axis. It means this point we have, it is minus 1. So the equation of this line will be x is equal to minus 1. So the required equation is x plus 1 is equal to 0. Next is find the equation of the line passing through the intersection of these two lines and parallel to the line y minus x is equal to 8. Again, these are the two equations, x plus 2y plus 3 is equal to 0. 3x plus 4y plus 7 is equal to 0. On solving both these equations, we obtain the value of x and y as minus 1. So these lines, the point of intersection means the new line that we have to calculate, it is passing through this point. Now it is being given that it is parallel to the line y minus x is equal to 8. So we can write y is equal to x plus 8. So the value of m we will have, it is 1. The line it is passing through this point and the slope of this line is 1. So the equation of that line, it is y plus 1 over x plus 1 is equal to 1. This implies us x is equal to y. So the equation of the line which is satisfying this condition, it is x minus y is equal to 0, or you can write x is equal to y. Next is find the value of k for which these three lines may intersect at a point. So first of all, we are saying we are talking about this first line and this last line, and we are calculating the point of intersection. So it is given 3x plus y is equal to 2, 2x minus y is equal to 3. So on solving this, we will obtain x is equal to 1 and y is equal to minus 1. So the point of intersection we have, it is 1 comma minus 1. Now we are saying this third line is also passing through this point. So this point should satisfy this equation. So we get k into 1 plus 2 into minus 1 is equal to 3. So this implies us k is equal to 5. So this is the required value of k. So what we have done, we have calculated the point of intersection of these 2 points. As all these three lines, they are concurrent, that is they are passing through the same point. So we are saying that this point should satisfy this third equation, and by substituting the value, we have obtained the value of k is equal to 5. Next is show that these three lines, they are concurrent and we have to find the point of intersection. So again, first of all, we consider these two lines and we calculate the point of intersection. It is x minus y is equal to 6, 4x minus 3y is equal to 20. If you solve these two equations, you will obtain x is equal to 2 and y is equal to minus 4. Now we check whether this point, it lies on this line or not. So we are saying 6 into 2, we are taking the LHS of this equation and substituting this value. It is 6 into 2 plus 5 into minus 4 plus 8. So the answer we obtained is 12 minus 20 plus 8 is equal to 0, that is equal to RHS. It means this point, it satisfies this equation. So what we obtain is that all these three lines, they pass through this point. We are saying we are having three lines and they are passing through this point. It is 2 comma minus 4. So this means that all these three lines, these are concurrent, and the point of intersection we have, it is 2 comma minus 4. This is the point of intersection. Next is, if the three lines, these are the equations given, are concurrent, then we have to prove this, result. We have to prove this result. Now, if these three lines they are concurrent, we are talking about the first two lines. It is m1x minus y plus c1 is equal to 0. m2x minus y plus c2 is equal to 0. Now, if we solve these two equations, we get x over minus c2 plus c1 is equal to y over m2 c1 minus m1 c2, that is equal to 1 over minus of m1 plus m2. So we obtain the value of x is equal to c1 minus c2 over m2 minus m1, and the value of y is equal to m2 c1 minus m1 c2 divided by m2 minus m1. These are these 2 points. They give us the point of intersection of these two lines. Now it is being given that this third line is also concurrent. It is also passing through this point. So if we substitute this value in this third line, we obtain m into, it is c1 minus c2 over m2 minus m1. Then it is minus y. The value of y we have, it is m2 c1 minus m1 c2 divided by m2 minus m1 plus c3, that is equal to 0. So if we take the LCM over here and open all these terms, we obtain the value as, this is m3 over here, it is m3 into c1 minus c2 minus m2 c1 minus m1 c2, then plus c3 into m2 minus m1, that is equal to 0. And by adjusting these terms, we obtain m1 into c2 minus c3 plus m2 into c3 minus c1 plus m3 into c1 minus c2, that is equal to 0. And this is the result that we have to prove. This is the result that we have to prove over here. Next is find the area of the triangle formed by these three lines. So we are showing these lines over here. This is the point A, this is the point B, and this is the point C. We are saying this, the equation of BC, it is x is equal to 0. The equation we have over here, it is y is equal to m1x plus c1. This equation we have, it is y is equal to m2x plus c2. Now if we solve these two equations, we are talking about these two equations, the coordinates we obtain, the coordinates of the A point we are obtaining, it is c1 minus c2 divided by m2 minus m1 comma m2 c1 minus m1 c2 divided by m2 minus m1. These are the coordinates of the point A. Then we are talking about the coordinates of this point B. We are solving x is equal to 0, y is equal to this. So we obtain that the coordinates of the point B, they are 0, c2. Coordinates of the point C we have, if we substitute x is equal to 0 over here, we obtain it is 0, c1. So we have obtained the coordinates of the point A, coordinates of the point B, and coordinates of the point C. So the area of this triangle, we are saying area of triangle ABC, that is equal to 1 by 2 mod C1 minus C2 over M2 minus M1 into C2 minus C1 plus 0 plus 0. So the answer we obtain, that is equal to 1 by 2 C1 minus C2 square divided by M1 minus M2 mod. So this is the formula, or we are saying this is the required area of this triangle, whose three sides they are given by these three equations. Next is find the image of the point P3, 8 with respect to the line x plus 3y is equal to 7 assuming the given line to be a plane mirror. So we are saying this is the line that we have. This is the line we are talking about, x plus 3y. This line we are saying it is x plus 3y is equal to 7. This is the point P given. It is 3, 8. We are saying this is a mirror over here. So we have to calculate a point Qx1, y1, and the property that we will have, that the distance d over here and this distance we have, they are equal. So we have to calculate a point Qx1, y1 in this form. So from this given equation, x is equal to, you can write y is equal to y minus 1 by 3x plus 7 by 3. So we are saying the slope of this line, that is equal to minus 1 by 3, and the slope of this perpendicular we will have, it is equal to 3. The slope of this perpendicular, it is equal to 3. So if we calculate the equation of this line PQ, the equation we obtain, it is y minus 8 over x minus 3, that is equal to 3, that is equal to slope. So the equation of this line we obtain, it is 3x minus y minus 1 is equal to 0. So this is the equation of the line PQ. Now we have the equation of the line PQ and we have the equation of the line AB. Equation of the line AB, it is x plus 3y is minus 7 is equal to 0. If we solve both these equations, we obtain the value of x is equal to 1 and y is equal to 2. We are talking about this point. We have obtained its coordinates, they are 1, 2. Now we know that this point n, we are saying this is midpoint of PQ. N is midpoint of PQ. So this coordinate 1, that is equal to x1 plus 3 by 2 and 2 is equal to y1 plus 8 by 2. So on solving this, we obtain the value of x1 is equal to minus 1 and the value of y1 is equal to minus 4. So the coordinates of this point Q we will have, that is equal to minus 1 comma minus 4. So these are the coordinates of this point. Next is the area of a parallelogram whose sides they are given by these four equations. It is a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. These are the four equations given to us. These equations we are talking about. Now we have to calculate the area of this parallelogram and we are proving that it is P1 P2 by sine theta, or it is this value, where P1 P2 are the distances between the parallel side and theta is the angle between two adjacent sides. Now we know that the area of the parallelogram, I am drawing this parallelogram again over here. This is A, B, C and D. And we are saying that the area of this parallelogram ABCD, it is equal to the half the area of the triangle ABD. So if we look at this triangle ABD, we are saying if we draw a perpendicular over here, this point it is M, we are saying this is P1, that is distance between the two parallel lines. Then the area of triangle ABD, that is equal to 1 by 2 into AB into P1. So area of parallelogram we have, it is equal to twice of this, so we get it is AB into P1. Now in this triangle if we are saying this angle it is theta, then the value of AB we are saying the value of sine theta we have, it is equal to, we calculate the perpendicular over here. This is the perpendicular length P2. We are talking about this triangle now. In this triangle, we have this angle is theta. So this angle we have, this is also equal to theta. So from this triangle, we are calculating the value of sine theta, and we obtain that sine theta is equal to P2 over AB. So this implies us AB is equal to P2 over sine theta. So we are saying that the area of parallelogram is equal to P1 P2 over sine theta. This is the formula for the area of the parallelogram. This is the first part we have proved, that the area we have, it is P1 P2 over sine theta. Now if we calculate the distance between the two parallel sides, we are calculating the value of P1 and P2. So P1 is equal to distance between the sides A, B and DC, and the equation of both these sides, equation of all these four lines, these are given to us. So we are saying the distance between these two lines, it is given by this formula. The distance P2 between the parallel sides AD and BC, it is given by this formula. These are the values of P1 and P2 that we have. So if we substitute these values in this formula, we obtain the final result in the form this. We are saying tan theta we have calculated. The angle between the two lines, the formula we know, it is tan theta is equal to m1 minus m2 over 1 plus m1 m2. We have substituted the values from the equation of the line. We have obtained this result, and from this we have calculated the value of sine theta. From the value of tan theta we have calculated the value of sine theta, and substituting it in the formula, that P1 P2 over sine theta, we have the value of P1, we have value of P2 and sine theta. We obtain that the area of parallelogram, it is given by this formula. Now the special case we have is, if P1 is equal to P2, then it becomes a rhombus. So this value, the area of the rhombus, it is given by the formula P1 square divided by sine theta. So this is the formula for the area of the rhombus. And we are saying if D1 and D2 are the length of two perpendicular diagonals of a rhombus, then area of rhombus will be 1 by 2 D1 into D2. And this last result we are saying, it is area of parallelogram whose sides they are given by these four equations. If the equations they are given in the slope intercept form, then the area of that parallelogram, you can substitute these values in this equation, you will obtain that the formula for the area of the parallelogram, it is given in this form. So these are certain results related to the area of the parallelogram. So we solve some question based upon this. First is, prove that the diagonals of a parallelogram formed by the lines, these are the four lines given, are at right angle, and also find its area. So we are talking about the distance between the parallel sides. We are saying the first we are considering, it is x over a plus y over b is equal to 1. This will be, we are talking about this equation. This side will be parallel to x over a plus y over b is equal to 2. This will be parallel to x over a plus y over b is equal to 2. And the distance between these two parallel sides, we are saying P1, it is given by mod of 2 minus 1 divided by square root of 1 by a square plus 1 by b square. So we are saying the value of P1 we have, it is 1 by square root of 1 by a square plus 1 by b square. Similarly, these two sides, these are parallel, and the distance between them P2, it is given by 1 by square root of 1 by b square plus 1 by a square. So what we are obtaining from this result, that P1 is equal to P2, and in a parallelogram if the diagonals they are equal, it implies us that this is a rhombus, and in a rhombus we know that the diagonals are perpendicular to each other. The diagonals of a rhombus are perpendicular to each other. So the area of this rhombus, the formula for the area, first thing we have to prove is that the diagonals are at right angle. We have proved that it is a rhombus, and we know that the diagonals of the rhombus they are perpendicular. So that is why we are saying they are at the right angle. And the area of this rhombus, if we substitute the values in this formula, we obtain the result in this form, and we obtain that the area of this rhombus, it is a square b square divided by mod of b square minus a square. So this is the value of the area, this is the value of the required area of the rhombus. Next is show that the 4 lines enclosed rhombus whose area is this. So we are given 4 lines. So we are talking about the pairs ax plus by plus c is equal to 0, ax plus by minus c is equal to 0. These are 2 parallel lines. Then we have ax minus by plus c is equal to 0 and ax minus by minus c is equal to 0. These are the parallel lines. So we have 2 pair of parallel lines, it means it forms a parallelogram. Now if we calculate the distance between these 2 pairs, the answer we obtain it is P1 is equal to 2c over square root of a square plus b square. If we calculate the distance between these 2 pairs, the answer we obtain P2 is equal to 2c over square root of a square plus b square. Clearly P1 is equal to P2, that is length of diagonals they are equal. So this implies us that this parallelogram is a rhombus. This parallelogram is a rhombus, and the area of this rhombus, that is given by mod of c plus c square divided by mod of determinant of a b a minus b. The answer we obtain on solving this, it is 2c square by mod of AB. So this is the area of this rhombus. This is the area of this rhombus. So we have proved that it is a parallelogram whose diagonals are equal, and combining these results we are saying it is a rhombus, and we have used the formula of the area to calculate the area of the rhombus, and we obtain the required result.